Hello all. We'll study the concept of today is the performance of demand paging. We have seen how demand paging is going to work, and in the demand paging you're going to have one problem, that is the page fault. Means like if we need a certain page inside the main memory for the execution, so if it is not there, we need to follow certain 6 steps which we have seen, right from checking into PCB, bringing the page inside the main memory and starting the execution of instruction where it was halted all over again. So this is going to cause you some overhead than the regular memory access time. So for in every computer system, a certain performance is there. That certain performance is called as MA, that is the memory access time. Okay, now this memory access time is very much equal to the demand paging time, like whatever we require time over here in the demand paging to access the memory. So it is somewhat same when we do not get any page faults. Okay, so the memory access time in normal and the demand paging time is going to be equal, somewhat approximately equal, if we do not get any page faults for the operating system. But then if we have certain page faults in the operating system, then this access time or the memory access time while demand paging is a bit more than the normal memory access time. So how do we calculate this? How do we calculate the performance of the demand paging? Is just having the rate or the probability of this page faults. Now you know a probability of any entity ranges from 0 to 1, and so the page or the demand paging access time probability will also range from 0 to 1, which we can name it as page fault rate or page fault probability. If there are no page faults, as you can see over the first point, if there are no page faults, then we can say that probability is equal to 0. But then every time if we require uh, a page, and every time we get it as a page fault over there, that means any page we require, none of them are present inside the main memory, then every time we get a fault, that is called as page fault. So it's going to be 100% page fault. So p is equals to 1. Okay, now how to calculate that? So for the access time of demand paging, we calculate the effective access time. We calculate the effective access time. How do we calculate that? So there is a particular formula, that is EAT, that effective access time is equals to 1 minus P, that is the probability of the page fault, into memory access. So that is the very default memory access time, plus again probability into page fault overhead, which can be represented as swap page out, page swap page in, restart overhead. So these four can be considered as the uh, page fault time required. So once again we can just memorize the formula: 1 minus P into MA, that is memory access time, plus P into the page fault time, you can say. Okay, so this is the formula. We require 4 entities over here, 3 to 4 entities, or rather we just require 3 entities. What is that? The probability of the page fault, next is the memory access time and for the computer system, and the page fault time, page fault service time. You can see over here that how much time you require to get out of this page fault, that is called as the page service time, page fault service time. So we can just have a small example over here where the memory access time is equals to 200 nanoseconds. An average page fault service time, that is 8 milliseconds. That means what? Like to recover from a page fault, we require 8 milliseconds to perform all those 6 steps. So it can be evaluated as EAT is equals to 1 minus P. So we don't have the probability right now with us, into 200 plus P into 8 milliseconds. So this can be calculated as 200 plus P into 7,990. Okay, it can be calculated as that way. With this equation can be evaluated in this way. So this means what? This means like if one axis out of 1000 causes a page fault, then EAT is equals to 8.2 microseconds. Now this is a slowdown by a factor of 40 microseconds. Okay, so this can be like, it is not asked in the exam, but if you are asked write a short note about demand paging, you can just place it in this particular way. Okay, thank you all.